All right, so today we're going to do ionic compounds. So that's between a metal and a non-metal. Between a metal and a non-metal. And that can be the polyatomic ions. So the metal is going to be your positive cation, and the non-metal is your negative anion. If you'll look at the bottom of your green periodic table, then on the back has all those ions. At the very bottom are your polyatomic ions. And they're all negative except for in the very last column. So the fourth column, the second box, you'll see the ammonium with the +1 charge. That's really the only positive polyatomic ion that we work with. All of our other ones are going to be negative. All right, so whenever you're doing ionic compounds, you have to leave the prefixes behind. With a covalent compound, there's more than one way that they can come together. So that's why you have to do a prefix with an ionic compound, because they have to be overall neutral. There's only one thing, only one way the cation and anion can combine. So you're going to always write the cation first, which is usually your metal ion, and the anion second, which would be either just a single anion or the polyatomic anion. And then you have to determine the smallest whole number ratio of cations to anions to make the charge 0 overall. The compound must be neutral. So in our covalent compounds, we had the prefix that told us what the subscript was going to be. On your ionic compounds, you have to decide what the subscript is going to be so that you'll get an overall neutral compound. You're going to use your ion sheet, which we have on the back of our periodic table, to know the charges. Also, a lot of the elements, you know what their charges are just based off of where they are on the periodic table. But if not, you have what you need there on the back. Formula and the name can have no charges with them. So in other words, as we work through these, you'll see that I'll be writing like the charge up here. That's just to determine what the overall subscripts need to be to make it neutral. You can't bring those over here and make them part of your compound. That will make it wrong. The charges cannot be with part of the formula. And if you're on the other part, when you have the formula and you're writing the name, it cannot be with the name. That will make them incorrect. All right, so let's just start looking at some. So I have this, I'm going to write the formula for sodium chloride. Sodium is a +1. That's from group 1. It's also on your periodic table. Chloride is a -1. Halogen also on your ion list. So I want it to be overall neutral, which means my positives must be equal to my negatives. In this case, that is already true. I have a +1 and a -1. So when I write the formula, I just write the symbols with no subscripts because I just need one of each to be neutral. So those are the easy ones. The same thing would have been if this was a +2 and a -2. I still would have needed no subscripts. They're already equal. Then we'll come to something like aluminum oxide. Aluminum is a +3 and oxide is a -2. So obviously they're not equal to each other. That's a pretty common combination. So you have to think to yourself, and kind of at this point, you're ignoring the negative because, and remember, you will never have a negative subscript. Because subscript tells us how many atoms we have. We can't have a negative amount of atoms. So I got a +3 and I have a -2. So what's the smallest number that both of them can go into? 6, exactly. 3 can go into 6 and a 2 can go into 6. So that means I want to have subscript so that I'll have a +6 and I'll have a -6. So we'll start with my aluminum. It's a +3. What do I need to multiply that by to give me 6? 2. So that's where my subscript of 2 came from. And then the same thing here. I have my oxide, which is a -2. I need it to be a -6, so they'll cancel. So what do I need to multiply it by? 3. So that's why I have a subscript of 3. Now I have 2 times 3 for my aluminum gives me a +6. 3 times -2 for my oxide gives me a -6. So then there is overall neutral. Another way to think of it is if you think of as your charges crisscrossing to become subscript. So in other words, my aluminum, that 3 will crisscross and become the subscript for the oxide. The 2 will crisscross and become the subscript for the aluminum. So then if you like it, prefer to think of it that way, then that would be Al2O3. Once again, kind of ignoring the negative because we're not going to have a negative subscript. The only time that doesn't work is if you have something like, okay, if we have magnesium sulfide. This is a +2. This is a -2. So if I think of them crisscrossing, and that means that 2's would come down. Mg2S2. And we have a formula like that. That has the same subscripts. No. So that's kind of, yeah, you would just need MgS. So that's kind of the only time it doesn't work. If your charges are already equal to each other, but they're opposite, then you need no subscripts at all. All right, so let's just start working through a few of them. We'll start with magnesium phosphide. Magnesium's a +2. Phosphide's a -3. And once again, those are all on your periodic table, on the back of your periodic table, not something that you need to memorize. So you have that 3-2 combination again. So smallest number they can both go into is 6. So I'm going to have my symbol Mg. What does its subscript need to be? It needs to be a 3 because 3 times 2 will give me 6. And then my phosphide is P. And what does its subscript need to be? 2. Now, if I have 2 times 3 for my magnesium, it's a +3, and -3 times 2 for my phosphide will give me, I think I said a +3, should have said a +6, and a -6, because so they'll cancel each other out. Or once again, if you like the crisscross method, my 3 came down and became my subscript for magnesium. My 2 came down and became my subscript for my phosphide. All right, magnesium oxide. Magnesium is calcium oxide. Calcium is a +2. Oxide is a -2. So I got a +2 and I got a -2. So what are my subscripts going to be that I need? Yeah, you're right. It ends up being CaO. Calcium is Ca. They're already equal, so I don't need any subscripts. I need a 1, but we don't write a 1. If you notice, some of these have a number, Roman numeral with parentheses behind the metal. Those are transition metals. If you'll look at your green sheet in the middle, Those are your transition metals, and they can have more than one charge. So like starting at the very top, chromium, sometimes it's a +2, sometimes it's a +3. Well, you need to know which one it is, and the way that you know which one it is by this Roman numeral. It's only used with transition metals that can have more than one charge. So it's actually kind of like a little shortcut. If I have a Roman numeral 2, that tells me that's a +2. I don't even have to look at my green sheet. Iodide is a -1. So smallest number that they can both go into would be what? 2. Cu for my copper, it is already at 2, so it doesn't need a subscript. My iodine needs a subscript of what? 2. Now, if you have a polyatomic ion like sulfate, you're going to pull the whole polyatomic ion just like it's written off of your ion sheet. So aluminum is a +3, sulfate is a -2. So we have that 3-2 combination again. So my aluminum, I'm going to put Al for my aluminum. What subscript does it need? 2. My sulfate is SO4. That's what makes up my sulfate ion. I got that off of my green sheet at the bottom. Since I'm going to need to give it a subscript, I have to put it in parentheses, and the subscript has to go on the outside. So what's my subscript that I need? You need a 3, and it has to go on the outside. Because we were trying to get to 6. Remember, we gave aluminum a 2, to 2 times 3 is 6. And then my sulfate is a -2, and it needs to be multiplied by 3 to get it to -6. So they'll cancel. If I'm going to just write this, y'all don't need to write it. If you would have put SO4 for sulfate and then somehow tacked another subscript on the end, that would be wrong. You have to put your polyatomics in parentheses if you're going to give it a subscript. Some people just like to always put their polyatomics in the parentheses, even if it doesn't need a subscript, and that's not wrong. So you could do that. All right, let's look at copper acetate, kind of a combination of things. This Roman numeral 2 tells me that copper is a +2. Acetate is in your very first column of your polyatomic ions, the 4th one down. It's that C2H3O2, and that has a -1 charge. So smallest number they both could go into would be what? 2. My copper already has a 2, so I don't need to give it a subscript. So my acetate, I take that whole thing, just like it is on your green sheet. C2H3O2, close my parentheses, and put a subscript on the outside. So what subscript does it need? A 2. And that would be my formula for copper acetate. All right, why don't y'all give those 5 in the next column 5? Today. All right, what did we get for the, we'll start with this one, the first one, iron bromide. BR2. Sodium sulfide. 2S. Lead nitride. 4, we had to get a 12 on each side. Potassium chlorate. 3. This ClO3 is your chlorate. So some of my students just like, when they take a polyatomic ion off, they put it in parentheses, even if they don't need a subscript, which so you could do that too. No, no, that would be wrong. You have to take the chlorate just like it is off of here. So if you look at chlorate, it's the second column, what, 1, 2, 3, 4, 5th down. That ClO3 with the -1. No, the potassium has a +1 charge because it's group 1. And then that whole chlorate has a -1. So they're already equal. So you just need 1 of each. And then lead nitrate. The lead is a +2, the nitrate's a -1. So since the nitrate needed a subscript, it had to be in parentheses. Probably the most common one that I get where people don't use parentheses is with hydroxide. Because hydroxide is OH. If you look, it is in that first column, the -1 charge, the third one down. And I don't know why, but for some reason, people like that's the most common one where they'll just stick a subscript on it without putting in parentheses. So hydroxide has to be in parentheses, just like any other polyatomic ion. All right, so we will now switch and go the other way. A lot of times, if you're given the formula and you have to write the name, it's really easy. The only time you have to kind of do a little extra work is if it is a transition metal. So we use the newest system, which is called the Iupac system. And that's where the Roman numerals give the charge of the oxidation number or the charge of positive ions only if they have those variable charges. So what that means is you're only using the Roman numeral is if you're using one of the metals in that middle box. If it's any other metal, you don't have to worry about doing that. The old system had different endings. So like you would have ferrous, and then you would have ferric. You don't need to write that down. But those endings told you what the charge is. But we're going to use the newer up-to-date one. So you just write the full name of the cation, the metal first. Be sure and use your Roman numerals if you're dealing with any of your transition metals. And then the last syllable of the anion is dropped and changed to "ide." Huh? It's not right. It's not writing. R stays the same for the polyatomic ions. So if it is a single anion, then you'll change the ending to "ide." But once again, that's already done on your green sheet. If it's a polyatomic ion, you leave it just like it is on your green sheet. All right, so let's just work through some of those. My first one, I have MgCl2. Magnesium's group 2. It's not a transition metal, so I don't have to worry about the Roman numeral. So I just write magnesium chloride. I don't have to use anything to tell me that there's 2 chlorides because there's only one way magnesium and chlorine can come together as ions. Next one, sodium, group 1. not a transition metal, so I just write sodium phosphide. Fe, so that is a transition metal that's in the middle box. So to figure out which iron is being used, you kind of have to work backwards. So I have nitride is -3. So which iron would I have to be using? And I have just one atom of it to cancel that out. Iron 3. So I would put iron 3 and then nitride. Next one, ZNS, zinc is in the D block. It's a transition metal, but it's not one that can have more than one charge. If you look, it's up here on your first set of anions. It's not in the middle box. So this would just be zinc sulfide. All right, on my next one, I have a polyatomic ion. So Al is aluminum. I'm going to name it first. And then whatever is left over, which is my SO4, I need to find it on my polyatomic ion sheet. So then you come and find the whole thing. It's down here under the -2s. Sulfate. So that is just aluminum sulfate. So if you have more than one element, name your first element and keep the other part of it together and find it all in your polyatomic ion sheet. Okay, why don't y'all try those last 3? Give them a try. All right, what do we have for Ca3N2? Calcium nitride. N is your nitride. PbCl2. Perfect. Lead 2. Chloride. And then PbO2. And lead 4 oxide. Exactly. Oxides are -2. I have 2 of them, so I had a total of -4. So I needed to cancel that out. All righty. So there's practice of this with the first practice you picked up. So try to do some over the weekend. We'll have a quiz over this on Tuesday. So then that way you can ask questions if you need to on Monday. And then we'll move on to acids, which is another set of rules. So it makes it so fun. All these different set of rules. So watch the video, please give yourself a little head start on that. Well, you tell me, what's a covalent compound? What makes up a covalent compound? What type of elements? Well, what are regular ones? Read it. It tells you right at the right there. The very first Roman numeral. On here, the very top. Mhm. Yes, exactly. Mhm. Yeah, so that's the thing, that's what, yeah, you gotta identify what you're naming, and then Monday we'll do acids. So then that'll be another one, so when you look at one, you gotta decide, because they'll be all mixed up on the test, you gotta decide which one am I doing, so you can apply the right rules. That's kind of one of the things that makes it a little bit more difficult. Also. I wanted to give you all a picture. If you have a note on your paper from yesterday about your handwriting, that comes from Mr. Anderson. He took this home with Brady. I feel like this means you're kind of this. I feel like that means that you're kind of in between. Like it said, she said, so did he say something like, well, you got nothing? Mine is writing better than those. Marco. This is good. Must be nothing. I feel like that just means you're just average. It's just so nice. No comment. That means you're in the middle somewhere, I think.
Yeah, you spell oxygen like super long.
Oh, yeah.
And I was like,
Wow.
Did you get excellent writing? What did you get?
Nothing.
You got nothing.
Just nothing.
Oh, yeah. Oh, that's what he said, wow. See, I'm so sorry.
I didn't get
Martha,
one
did you
of
go
them.
well? Yeah.
Oh, yeah, I did. I put it down there. I put carbide and then I put oxygen.
Yeah, but you didn't get that.
Is that like a wow good or a wow like?
Well, it's
Because
wow
sometimes on my AP
exclamation
chemistry
point.
kids, I'll put like a wow, like, really? That's all that you studied for that?
No, it's wow.
My wows are not nice. Wow. Wow, that's really all the effort you put in, or you even take it everything. Have a nice weekend. I still was, dang it, I hate when I do that. Forget to stop recording.